we are facing. In we have many challenges worldwide because end of the day, chip is a product. Chip is a consumer product. Everybody wants in their life in the form of washing machine, air conditioner, smart home, even your mobile phones, laptop, gadgets. Everywhere there is a chip. So chip has become a common friend. I would say it's a very good friend of everybody now. We are spending more time with the chip indirectly or directly most of the time. So we should at least know, being electronic students, it's your responsibility to know more about the chip and the chip designing process. Okay, we'll also discuss on the career growth and future scope. You're very much welcome to Semiconductors. So we'll help guide in the process, and I'll try to help you out. Um, what are the ways to enter into semiconductor, and what are the salary packages? We will discuss that as well. Okay, so first thing, before going to technical concept, I just want to address few important things which were not taught at our times 10, 12 years back when we started, when we finished our graduation. Really, no one helped us. No one has provided any kind of information regarding there is an industry out there which is having real-time work environments of semiconductor, the core working domains of semiconductor. We just know that, okay, there is a system called embedded systems where you start programming chips, Arduino boards, PCBs, handling PCBs, and other embedded IC environment. But we never know the VLSI when when we are pursuing graduation. So that is a lack of awareness. We lack awareness because no one guided us. Okay, so the major things that you will come across is lack of guidance and lack of motivation. Both are very much important to any student or any person who wants to settle down or enter into a success path, either in the education or in the business or any any journey path of a person. He might lack guidance because everybody is busy in their own way. Nobody spend time. Nobody bothers. Why? That's not my work. He has to uh, grow on himself, or he has to. It's his job. It's his life, and many of the times nobody listens to seniors or somebody who's trying to guide. So there is a big misunderstanding, and because of that misunderstanding, I have seen people or my fellow students or my classmates from the same batch. It took 5 years, 8 years for them to settle down. Where few of us settled in the early stages of our career journey because of uh, specific guidance. Even I had to go through certain courses, trainings to enter into semiconductor. So guidance plays a major role, and motivation. Motivation is it's your own motivation. Nobody helps you motivate you to study. Parents motivate you, faculty in your colleges, academic curriculum. They just motivate you, but it's your own responsibility. So it's everyone's responsibility to motivate themselves to what to become what in the next few years after graduation, what, or after intermediate, what, why you are studying electronics engineering. So your parents or faculty are doing their part. It's also our responsibility to do our part, have our own self awareness. So lack of self awareness is also very danger. And I think there is a film I felt very happy. Mukunda, low aspiration is an international crime. I hope many people can have seen that. I'm not sure, but it's true. Lack of self awareness is the biggest mistake for all the young engineers and aspirants, uh, because of which they are not getting settled or becoming unemployed for a longer time. Okay, so like what happens when you have low awareness or lack of awareness, particularly the self awareness? What happens? You start doing micromanaging means you start finding some people under you who listens to you, and you start commenting on them. So there are many things. Micromanaging is very bad, even in the when working in your job environment. So that is one symptom that you see when you lack self-awareness. So one more thing, when you are not aware of your own emotions, when you are not aware of your emotions, you are unstable. So that is also very dangerous. And when you lack few things and your self-awareness also, you start becoming aggressive, and you start you will be always in a defensive mode. So okay, somebody you have to defend yourself from your friends, colleagues, family. If they are going to ask some question that you might not know the answer, okay, say something different answer, or try to go in a defensive mode and try to create a barrier. Just but that doesn't help. That is for that particular moment, but later your it's uh, it's indirectly or directly spoiling you, because you cannot just bypass the day or bypass the time. So that is also a symptoms, and you start making excuses when you lack self awareness. And few people uh, might correlate. You start bullying people, okay, when you lack self awareness. So all these are the symptoms of lacking of self awareness. Okay, so please take some time to understand this is your perfect time. After your graduation, there will not be any time to sit and think, okay, what to do, uh, and correct yourself, or understand yourself. It will be busy life, because you are done with your academics or education. So everybody's concentration will be on you. What next? So a wise person always will have self awareness. Okay, and you guys are not kids anymore. So this is uh, as a brother, as a mentor, I feel uh, responsible to help the upcoming engineers. Okay, so this is just a self guidance. Please try to understand, and please have self awareness, and please do not do any of these activities that will show lack of self awareness. That means you are afraid of something. Okay, so yeah, it's lacking of self-awareness and having self-awareness, the differences you'll understand. You'll understand by having hurdles in your life. So parents or faculty or any mentors try to advise you or mentor you. The only reason is that, okay, they don't want you to see all the bad stages in your life, all the hurdles. Try to avoid the hurdles and take a soft path or a even a hard path, but a straight path. Okay, so have your own self-awareness. It's nobody's responsibility. It's individual self-awareness responsibility. So it's up to you. Okay, so be stable in your life. Don't be unstable because you are not in that stage. Okay, so obviously strong motivation, clarity in life, and correct guidance definitely will give you success. It's practical. This is not just theory. It's practical. I have seen it with me, my friends, colleagues. Today, I have worked with top MNC companies, top one semiconductor companies in the world. I have worked with senior scientists in a team where I haven't imagined I would work with them. The mobiles or laptops that you're seeing, i3, i5, i7 generations, I was part of the design for the latest advanced packaging and technology. So I would like to share some technical concepts with you. So first, these are the owners, or these are the first person or the inventors who paved path to our current IC world. So if you are seeing an IC today, because of a few of these engineers like Robert Norton, Klein, Kevin, okay, and Federico, there are many engineers who started the world of integrated circuit IC. So the first thing, the Robert Norton in 1927 and 1990, he lived up to that period of time, and he used to be called as mayor of Silicon Valley. And he was an American physicist and an entrepreneur. So this group of people, along with Robert Norton and Kevin Klein, John Sears, they all worked with uh, Bell Labs. Bell Labs, and they have started Fairchild Semiconductor. They are also part of Intel Corporation. The first semiconductor companies. These are the first semiconductor companies, and I have worked with Intel Corporation, and I still have uh, working relations with Intel Corporation. So I see that there are all the engineers coming from, um, particularly from India. Many of my friends are from the same places: Andhra Pradesh, West Godavari, East Godavari, Rayalaseema, Prakasham, all the colleges. I have seen many of my colleagues coming from your work area, I mean, your place, and working. So there is no barriers here. Everybody has to start at some point, but please have a, uh, a correct guidance, take your correct guidance, and go in a correct way. So these are the engineers who has helped us to be and to use our uh, mobile phones or laptops today. I don't want to go in depth of what they invented, but I just wanted to bring his notice. So when you are pursuing engineering, particularly in final year of engineering, and hope you are from Prakash Engineering College, comes into JNTU, right? Your academics is syllabus is from JNTU?
No, they're basically from Bangalore. I think Pace College.
Oh, okay,
Not
right,
Pace.
correct. Yeah,
So
there
might
is.
be they recommend VTU.
Yes, yes. Okay. So either of any university coming from UGC, University Grants Commission, uh, gives you the syllabus, right? So the engineering final year, you'll come to understand, okay, VLSI design, microprocessor, microcontrollers. These are the two common subjects I think everybody will come across from electronics background. So the understanding from academic to the industry is a very huge gap. So the gap is so big that you definitely has to get a proper guidance before coming into industry, and industry also welcomes to the people who has uh, met the I mean reduce this gap from academic to the industry, because industry is totally different compared to what you learn in academics. In academics what you learn is ABCD. To be very precise, it's just you learn the alphabets of electronics, the basics and the fundamentals. But industry is far more advanced, and we used uh, the advanced technologies. So these are the beginning pillars of any IC. And let me bring CPU here, microprocessor, and microcontrollers unit. Okay. So you all know the difference between this microprocessor and microcontroller, right? I think you are learning it now. I'm not sure you are done with learning this, but you know the difference now, right? So microprocessor is just a processor. The name itself, it's a processor. So it will have an ALU, registers within. That's it. There will not be any RAM, ROM part of your CPU. Everything will be outside, connected or interfaced on a board. And whereas microcontroller, which is very helpful in IoTs, home automations, and many application specific integrated circuits, it is very helpful microcontroller. So pick microcontroller, 8 mil, 8 mega microcontrollers, ARM, ARM7 microcontrollers. All these microcontrollers are very helpful. The reason they are more resourceful than microprocessor for certain applications is that they have inbuilt RAMs, ROM, timers, and interfaces, the serial interface within the single chip. So the purpose of microcontroller is totally different compared to the microprocessor. You use microprocessor only when you have a complicated functionalities and you want to use it in a high production customer usage where you want more functionalities to be embedded. So CPU is a single IC. Okay. Remember that CPU microprocessor, if you're saying microprocessor, it's a single IC always. Okay. It will have the basic arithmetic logic unit, which will have all the functionalities that can perform arithmetic logical operations, Boolean, trigonometric, whatnot, everything. Okay. So this is a basic understanding. We'll see going forward with few circuitries. So this is one of the advanced SoC on top of Raspberry Pi. Thunderberry 5 is using Qualcomm Snapdragon processor. Okay. So what you see here is a IC processor, Qualcomm Snapdragon processor with all the peripherals connected on board. So all these are externally connected and they are all sitting on a same PCB board. Okay, so as a VLSI design engineer, you design this particular IC. These are all analog components. So there is a big barrier between analog and digital. So analog design is also a separate designation in real time. Digital design is different. In digital design, the digital design cycle is different. Okay, and it has many stages which will go into fabrication, starting from RTL design to the fabrication stage. So which we'll see that. And these are all analog. All these are analog peripherals or components, and each component is manufactured by a separate company, separate manufacturer. So not necessarily that uh, you have a product, you are going to sell it in the form of mobile phone. On a single mobile phone, you will have multiple small ICs, multiple components, electronic components from a different vendors, multiple vendors. So each vendor is expertised in manufacturing that particular component. So not everybody will be expertise in all components. So far, there is no such company that can produce, manufacture, and bring up a end product that can give it to customer, which has end to end of their own fabrication, their own products from that company. There is no such company so far, even Intel. So there is this vast difference from the reality to what you see. You buy mobile phone from shops, laptop, or all the electronic gadgets, but internally there are multiple ICs manufactured or made or designed by multiple manufacturing companies. So here is one example that you can see. So many of you guys have really no idea of the real chip designing process. So what you see on the right side is a Samsung mobile SoC or a motherboard of a Samsung mobile. So if you see here, majority of portion is occupied by the battery, and the rest of this particular PCB board that you're seeing is the only uh, PCB that is handling entire mobile SoC. So you have Snapdragon processor, flash storage, and current and voltage sensors, thermistor terminals, temperature sensors, audio codec, RF fusion, Skyworks. So this is the only small portion that you see. This is the actual implementation when it comes into a product. So your digital IC is just this much only. What you see here, these are the few digital ICs. Rest of them are components, analog components in a small size, micro and nano sizes. So this particular left side, what you see is within the CPU or the Snapdragon processor. So Snapdragon processor will have all of this within this particular IC. This within this square box of IC that you see will have all of these components within. So you have ISP, GPU, power management system, accelerators, sensors, all compiled into a sensing hub, security module, processor security module, Why you need a process security model? Because you don't want your IC to be misused or copied by any other third party vendor, because you have many competition in the market. Anybody can copy your IC. No, it doesn't happen like that. Even from the starting from 8096 processor to the 8052 microcontroller, all ICs have security which they cannot copy. Okay, so there is a Cairo CPU, 5G modem, RS system. This particular mobile phone supports 5G modem. That feature has to be within this Snapdragon chipset. You have fast interconnect and within memory. So all of these components within a single system. This is called system in packaging. So when you have system in packaging, you will see all these components in single IC. So there are types of packaging. Depending on packaging, you can have. And this system in packaging SIP came into existence, I think, in 2005. Starting 2005, we have it, and we used it in first mobile design. So when mobiles came in, we had system in packaging. Okay. So as I said before, this is some Apple motherboard. So if you're seeing an Apple motherboard on an Apple phone, that if you remove the battery space, this is the actual portion of your circuit, and you have many components here. You see, I mean, it's little blurred, but I can help you guide. Okay. So this particular A14 is a Apple processor, the first Apple 64-bit hexa-core application processor. Okay, and it has within inside. This is also a system in package. Because of system in package, it also has the Micron. Micron is a company. It's a semiconductor company. Micron MT53D 6 GB mobile SD RAM. Okay, so it's a 4-die package. That means within this particular IC that you see, okay, within this chip, it is designed in I think A14 basically designed with 5 nanometer technology. So 5 nanometer technology, if you are designing, then you have SIP with heterogeneous packaging where you can have multiple dies. Okay, we will see what is the die and all going forward. Okay, let's not take much time on this. So you have from Micron, and this is the Apple mobile set, right? Within Apple, why there is another company I see, Micron. Apple can have its own, right? So you have from Micron, you have a synchronous buck regulator from On Semiconductor. On Semiconductor is one company. You have a Taptic engine driver parallel to buck regulator, which is from Analog Devices. It is Analog Devices is a one semiconductor company. And you have a DisplayPort multiplexer. This is coming from NXP Semiconductors. So see, if you see to design one mobile SoC or a motherboard or one mobile phone, to be very precise, how many manufacturing companies are involved? Texas Instruments, Texas Instruments, ST Microelectronics, Apple with collided with Cirrus Logic for audio amplifier. So see, if you see how many external vendors are sitting. Okay, so there are many manufacturing companies that has all the design, assembly, and testing mechanisms. So lot of engineers are still needed and we'll see what are the designations we have. So this is your cycle. Your the digital IC or any, not, let's not say digital IC. You can say an integrated circuit with CMOS design or by CMOS design. Okay, this is a cycle. So let's see a little glimpse of this cycle. Okay, in real time, if a chip has to be designed, any chip any chip has to be designed, it has to go through this cycle, this process. So you come up with a specification that, okay, I need a mobile phone with these features. I need this much of clock clock speed. Okay, like I need 4.8 gigahertz. 2.4 gigahertz is not sufficient. I need 4.8 gigahertz. I need this functionality. It should support 5G network. It should have a latest Wi-Fi module, latest Bluetooth. It should support USB, latest USB module, and display should have AMOLED, and graphics. It should play the latest and hard coded uh, the gaming. It should support high end gaming. So all these specifications you come up with. Okay, you need a two sims, dual sim, single sim. It need a extra external memory slot. Okay, so all these are coming to specification, and you tell it to the customer. Like Samsung, Samsung has its own manufacturing unit. Let's take OnePlus. OnePlus is just a fabulous product company. It doesn't has its own fabrication unit. It depends on another company. So, for example, OnePlus is coming to Intel. Intel has its own manufacturing unit, or it has a fab. Now, OnePlus says that I need this mobile SoC to be designed. Are you willing to design? And you have to do everything end to end. And this IC need to be taped in, and I'm expecting production also within your manufacturing company. Then OnePlus becomes your client. OnePlus is a client to Intel. Okay. Now Intel has to start piling up the resources, engineers. It has to make ready all the arrangements to start designing, testing, assembly, packaging, and shipping. So it has to start with the chip specification, and they come up with a blueprint. They architects, there will be senior architects like 15 years to 20, 22 years, 25 years, or 30 years of experience till that period also. Okay, starting from 8 years, everybody participates. 8 years of experience, everybody participates in the design specification from the client. So you give your expertise input. Okay, so like that you come up with a chip specification, and you start uh, doing the architectural work, and you come up with a floor plan. Not the physical floor plan. It's just a it's something like you want to construct your house. You purchase a plot, and you go to the government agent and get the plan. You get the plan, right? Based on the plan, you get a loan. You get all the approvals. You get you grab up all the resources for the construction, and the construction starts. In the same stage, every industry has the similar cycle. This is particularly that we are working on circuit designing or chip designing. So it's the same process. So RTL design is one designation. Senior architect is one designation. After RTL design, you write the code in Verilog. That is RTL design. After that, you do verification, functional verification. Then you have a domain functional verification engineer. So that is one domain. RTL synthesis, one more domain. You need to synthesize the RTL. Okay, partitioning of chip happens across. You don't need a separate unit for partitioning. So the most important and crucial domain that came into existence starting from 2005 is design for test, DFT. So DFT is one of the biggest and important domains in semiconductor cycle. So this is one domain where you insert additional test logic so that uh, you give the opportunity or functionality, additional functionality to that particular IC to get refurbished later after manufacturing, later in the sense of post manufacturing. You are giving the functionality of or additional benefit of debugging, diagnosing, refurbishing. So if your mobile phone is heated up or you have some, it got shut down uh, unknowingly and you just went to the technician, he says that there is some defect, we need to send it to the manufacturer. It will take some 15 days or 20 days or 45 days or 3 months even. Then this particular IC comes back to the manufacturer and he has to diagnose your mobile phone through the input of USB. Through USB, he will try to access your entire chipset. So how is he able to access your entire chipset just by connecting through chipset USB of your mobile phone? That is possible because of JTAG and DFT methodologies, the logic that you add through DFT. Next, floor planning, physical design. All these are one domains which you physically implement your design, your whatever RTL code he has written, that will be implemented on a physical environment. Assuming the tool, we use tools. So the semiconductor entirely depends on EDA vendors. EDA, EDA tools like Mentor Graphics, uh, Cadence, Synopsys. So these three are the biggest vendors, and we depend on close to 80%. 80% of the time, semiconductor, any domain that you see in the cycle, they are dependent on these EDA tools. Without EDA tools, there is no semiconductor. Even now, even before, okay, without the tool, without the software, without the EDA tool, we cannot finish up semiconductor IC. You will not have any mobile phone without EDA tool. Okay, so EDA tools play a major role. So all this process can be implemented if EDA tool supports it. Okay, it is simpler for your understanding such that you are having MS Office, latest MS Office version, but you have a operating system of Windows 7. You cannot install, right? You cannot install a latest version of MS Office in a Windows 7 old operating system, right? So anything, this explanation is just be a software perception, but if you're talking about a chip designing, if a chip has to support, then you have to design it, and you have to design it, you need to use a tool, that is EDA tool. Okay, so all these stages that you see from 6 to 11 all come into physical design, physical verification, layout. Okay, so all are into a single working domain called physical design. So physical design engineer has to learn through all this process, but he has, in real time, he will be expertise in doing only one thing. Either his expertise in floor plan, placement and routing, CTS. Okay, likewise. And once this is done, you give it to fabrication, where you will do on a wafer fabrication. Okay, and you do packaging and testing. You will see. We will discuss on that. Okay. Okay. So, what do you see in this image? Product design, backend, wafer fabrication process. So all these are part of your semiconductor process. In short, accumulated in one place. What you see is product design, that is called front end, where you are in a designing phase, that is front end. Back end is something where you, once your IC is done, designing is done, you want to test it on a physical wafer and you want to create a physical IC. All those comes into back end. Now, IC design, once your design is done, ready, you start making wafer. So you already have wafer in market, you buy it depending on a requirement and size. So wafer will be cut into multiple pieces, square pieces, or the size of the IC that you wanted to design, depending on the package. You uh, integrate that particular design onto that particular die on the wafer. Okay. So the same process: RTL design, verification, design for test, physical design, signing off to ATE. So this is a cycle and this is a process. So in the entire process, wafer, wafer plays a major role. Without wafer, there is no IC again. So wafer is a substrate. Okay. So I'm not sure you guys have already started learning VLSI design subject. You already started? Do you have the subject VLSI design,
Yes, sir.
CMOS design? So you guys know the CMOS fabrication steps? I'm not going to ask you entirely, but I hope you have seen that fabrication steps, starting from taking a substrate.
Actually, all these topics are new to them. They have not started. They have to start in 6M and some students
Mhm.
have to start in 7M.
Okay. Fine. So these CMOS fabrication steps are all part of your academics as well. The same, we will go with the same process, but in advanced fabrication methodologies. Okay. So the wafer is a substrate, silicon wafer. It's a silicon wafer made from silicon. Silicon is again extracted from sand. So from sand, we take the unpure silicon and we filter it multiple stages and then we make it into a proper wafer. Okay. So these are all the process involved in wafer fabrication. Just only wafer. So if you have a wafer, it's act like a PCB for you. To be precise, for an IC, you depend on a wafer. On wafer, you start etching your gates, all the transistors, all the design will come on wafer. It's like a pizza. Okay, you take a bread. On top of that, you place all of your what we call the vegetables or the any item that you want on a pizza, right? So the wafer is like a the bread. Okay, so we'll see a little bit more on the wafer, how a silicon wafer is manufactured. Okay, is a silicon extracted from sand will be poured into ingots. Ingots are molds. Okay, so you need a circle shaped wafer. So what you want to do, you want to pour that silicon that is burned in high temperatures. Okay, and you get a pure silicon and you pour into the ingots. Ingots are the shapes of which will look like a bullet, the gun bullet. Okay, so the shape of a bullet that we'll place in the molds. Okay, that is called ingot. Ingot uh, uh, is a mold which will have all this silicon poured into it, which will later become a silicon ingot that will slice it. So we'll slice based on the thin thickness that you want, the kind of wafer that you want for your IC. So you take that wafer by slicing it like this. Okay, so wafers are sawed out of ingot of pure crystalline silicon. Okay, and they are polished. After polishing, they go into deposition, material deposition, to become a proper silicon that we want. There will be impurities also. Okay, sorry. Give me a second. I hope the screen is visible. Yeah. So there will be material deposition similar to the conversion of semiconductor material, the P type, N type, based on the impurities you do. So you try to add impurities to make the required behavior, to get the required behavior. So silicon, you want a pure silicon. So you do all the material depositions or modifications required. Then you do some spinning to achieve a uniform layer. Then you come up with UV lithography. So which will this lithography will help you uh, create a proper silicon layer. Okay, which will also create the chip patterns. You need a square shaped, the size of a wafer, I mean size of a die. Okay, die, we call it a die, uh, on which your IC will be designed. So on a large wafer size, you will have multiple dies. Okay, they are properly cut and like this square boxes that you see. So in order to get that shape, you have to do UV followed by etching and heating, ion implantation, and any the resistance is there to be removed, that will be removed. And you will go with wafer processing cycle. Okay, so again, this will not, this is just a single cycle. It has to go multiple times to get a perfect uh, IC. Okay, so once IC, I mean, once the wafer is ready, you cut into individual dies or the chips and you test it. Then once you tested it, then it will go into that packaging. So whatever the pins that you see for an IC, if you see an IC, and I'm not sure you have seen a physical IC in your lab, you might have seen in the breadboard, even the EC labs, a physical IC. It has a pins, right? I'm sure you might have seen in real time already. So the IC will have pins depending on the package type: single inline package, dual inline package, quad flat package. I mean, the pins are at only one side of the IC, that is called single inline package. If the pins are on the left and right side of the IC, then it's a dual inline package. And quad flat package means quad, four sides. The pins are on the four sides of the IC, then it's quad flat package. So likewise, depending on the package, you do packaging and assembly the chip. So this is a total chip fabrication steps on a physical level. Okay. So moving on, this is a fine tune with the machines that you see, the wafer to packaging, the fine tune machines. These are the machines. So even mechanical engineers, okay, even mechanical engineers will have jobs in semiconductor, because majority of the times, as I said, in designing we use tools, in manufacturing we use machines. So entire work is done by machines, because we end up bringing lot of moisturization and dust particles into the fabrication unit. So when you enter into a fab where ICs get manufactured, you will dress up like a I mean, you had seen people going into NASA satellites, aerospace. You end up wearing all the suit, right? So when you go into the lab, okay, I have worked in Malaysia, and the Intel fabs I have gone many times. So you have to wear the suit to enter into fab, so that no dust particle, even a minute dust particle, should not go or roam in the air, okay, which might destroy the fabrication process. So machines will handle majority of the time. Okay, give me a second, guys. Okay, so I want to make it little fast. I think I have taken much time. uh, okay. Okay. So machines will do the process of wafer cutting until the packaging. So end-to-end semiconductor process, apart from the designing front end, everything will happen in the back end through machines. So uh, even mechanical engineers get to work in the semiconductor industry. Okay. So these are the tester equipments on which the finally, once you finish your design and you want it to be tested before getting into the market, or before you mass produce the ICs, the IC has to be whatever you have designed. It needs to be tested. So as a DFT engineer, okay, I particularly worked as a DFT engineer. So uh, as a DFT engineer, whatever the test patterns that you deliver, or you create the test patterns, that will be used on the tester environment physically to test the IC or the design on a silicon wafer. Like around 2000 to 5000 wafers will be tested. If you are happy with the results, you will go with the mass production. Okay. So there are few trends that we see: semiconductors, IoT, artificial intelligence, advanced materials. Advanced materials, we'll discuss a little bit of advanced materials later. Novel architectures, advanced packaging, 5G, in-house chip designs, fabrication technologies, automotive chips, sustainable manufacturing. So there are 133, 36 companies that are working in the world only on these innovations, on the semiconductor innovations. And this is the latest 2023 analysis provided by Starters. This survey is the latest and recent. So there are many companies that you don't know out of India. In India, we don't still have our own fabrication unit. Fabrication units are still going on with the Make in India concept. So it's a good thing. We have more opportunities within India going forward, and particularly for you guys, those are coming into semiconductor, you will have a very good packages, high salaries within India. You don't need to go abroad. So these are the materials, the gallium nitride. So we moved on to gallium nitride for high speed applications. We are not still using silicon. We moved on to gallium nitride, and we also have silicon carbide, SiC, which we use for railways, inverters, solar panels, and all. Even we use for gallium nitride for automations, data centers, mobiles, laptops, which gives a better performance. Okay, so this is the difference between the silicon and gallium nitride based on the performance. The advanced fast chargings, the fast chargers that you get with your mobiles, the latest mobiles that you purchase, starting from 25 watts to 65 watts or 120 watts, the fast charging capacity is possible only because of gallium nitride. Okay, so there are many useful advancements within gallium nitride, and there's a huge market. So going forward, the trend is gallium nitride. We no longer use silicon for the advanced technologies. So these are all the companies starting from Dell, MI, Nvidia, Oppo, LG Electronics, Realme, Xiaomi, Amazon, whatever you see the fast charging, all are using this gallium nitride. So this is important slide. Please pay attention. We'll close. We are concluding almost. So these are the companies, total companies, not total. Okay, overview. Okay, on an overview, the top 5 companies or top 10 companies I have listed. So if you see, these are categorized into foundries are and fabless and suppliers and vehicle OEMs. So these are all the customers. Okay, these are all the customers. Even these are all the customers. These are all the customers as well as manufacturers. So these have, and the foundry means they have their own fabrication unit or a manufacturing unit. Amcor, JSET, SPL, AC, UMC, Global Foundries, SMIC, TSMC, Samsung, Intel. I did not include Intel here. Intel. So these are foundries, and these are fabless. Fabless means they do not have their own fabrication unit, so they depend on this fabrication unit. So anything they have to design, they have to take the libraries of these foundries for the technology node. If you say 5 nanometer technology, if you want to go with 5 nanometer technology, you have to approach any of these vendors, manufacturers, okay, and make sure that if you are designing something using their technology node, then you have to give to manufacturing or a enter production, chip production to that manufacturer only. You cannot change in between. Okay, so all these companies depend on foundries. So that is one reason India, we are trying to bring up our own make in India concept, and there is a big funding happening in the semiconductor. We are going to have our own fabrication unit. So supply chain disruptions, these are the challenges that we have currently. Technological complexity and mineralization, we are not able to bring quality control, yield, time to market. because of the various reasons, because of recent COVID, Russia-Ukraine war, uh, America and China trade issues. Many things are happening in a geopolitical issues that are that end up creating chip shortage, and there is a talent shortage also. So talent shortage, these three parameters are from the worldwide survey conducted so far, and this is the biggest thing that is needed. We have a big talent shortage in semiconductor because many people coming from EC background or electrical background end up working in software. So when you graduate from one engineering domain and end up working in some other engineering domain, that doesn't make sense. And because of that, what happens is in semiconductor there is a lack of talent, and we have shortage of talent. That is one big thing that we have. We don't have engineers. That is why those who are working, we are highly paid. We are very highly paid in the market compared to any software company or software engineers or any other engineering group. VLSI engineers are highly paid. Okay, because of shortage, and shortage will always be there because this is a digital era. Going forward, technology gets improvised. Technology will never be minimized, right? Or it will not reduce. Technology gets growing up, going forward. So we need more resources. Resource in the sense the young aspirants, engineers. Okay, so material science, device physics, process engineering, RTL design, DFT engineers, physical design engineers, design verification engineers, all are required with the skill. So the main important thing here is from academics, you cannot directly jump into semiconductor. And we don't need to learn uh, new technologies day to day to keep our job, unlike software engineers or any other working domains. Our fundamentals are the same: combination logic gates, flip-flops, muxes, multiplexers, full adders, half adders, counters. The combination logic gates and the truth tables are the basics, and the Verilog coding is the basic. There is no other fundamental even in the industry side. So that is same. What you learn in your academics, if you want to come to semiconductor, what you learn in your academics, that is very helpful, and that is if you are coming to the same working domain, you will be learning or working with this combination logic gates throughout your career. You don't need to learn new concepts. On the working process, you will try to learn the advanced technologies and methodologies once you get into job and work. So getting into semiconductor, your academics is sufficient. Whatever you learn, you will be learning going forward. As Saul said, uh, VLSI design that you learn in the subject in your academics, that is going to help you get your job in semiconductor. Along with that, you need to have experience using the EDA tools, because as I said, 80% of the work is done by the tool. Only 20% the engineer has to handle the tool to get the our required output. So we, as Success Bridge and other training institutes, we fill the gap by providing that skill, by training you guys on the industry used EDA tools like Synopsys, Mentor, Graphics, Cadence. Okay, so this unlike software, there will not be any additional training given into semiconductor companies. So once you get a job, you have to come with the trained. So only trained engineers are accepted in the semiconductor company. If you are not trained, no semiconductor company will accept. not like a software. You just learn Java or some other course and you enter into software. Okay. Here, whatever you learn in the academics, the VLSI design, you learn the tool, uses of tool with the help of any training institute and get a job. So there will not be any additional training given after you get into job. So this is a skill gap which is fulfilled by institutes like us. Okay. So this is the lack of awareness that we see from academic institutions, all the institutions. They are not aware of the industry and what is the gap they have. So the gap you have is the industry tools. To understand and learn the industry tools and the methodologies, how this industry tools works, you definitely have to learn it. Then only you can get a job and settle in semiconductor, the core electronics background domain. Okay. So starting from Andhra, Karnataka, Telangana, I have seen all engineering, the top universities are tying up with this awareness program that the current program that we are having now. This awareness, your college is doing great. I would say your college is doing very great, trying to fulfill your gaps, the skill gaps, by tying up with us. Okay, so any gap you have, people want to enter into semiconductor, the core domain. Okay, they can easily enter now. You get a path now. We become the bridge between you and the company. We teach you the industry trainings and help you in getting into semiconductor company. So this is happening across all the countries, and within India, within our Karnataka, because Karnataka is a place where all the semiconductor companies are sitting. Even we have in Hyderabad now, Hyderabad and Bangalore. So these are the two places that we see all the major institutes are taking up multiple programs in fixed term programs, internship programs. Okay, and we are tying up with institutions to provide awareness of the industry and help train the young aspirants. Okay, so these are the basic salaries. Okay, that you see, and these are the four major working domains. I have not mentioned analog design, RTL design, decision verification, DFT engineer, physical design, and there is one more domain, analog design. Analog design, the salaries are a little bit less compared to the digital life cycle of semiconductor. So a minimum 6 lakh package you will get from the introduction, and within 5 years you will see 2 lakhs take home minimum. So that is very less. I mean, very rarely seen within India. Okay, in software domain, but in semiconductor, any company, even you work in your hometown, also you can still earn this package because lack of resources we have. We don't have that many resources, but we have many openings. Okay, many openings in semiconductor. Now new fabs are coming into within India. There are many openings. In the next 5 years, there will be huge openings for you all with a huge demand. Okay. Any questions?
Any questions are there? You can tell. Any questions from the students?
Hello, sir.
Yes.
My name is Alvin D'Souza. So asking internship in any semiconductor industry is hard. Why is it so? Like they will ask for the minimum experience, so they would not take as a intern or an internship.
True, true. So it's a valid question, and it is the same question is within everybody. Let me answer to that. As I said earlier, in semiconductor industry, if you want to enter into semiconductor industry, you have to get trained and then only you can enter. Without getting
Yes,
trained on the industry tools, you cannot. Because in academics, so for example, in your college, you will not have the mentor graphics or synopsis or cadence advanced industry tools that are required to start working in any of these designations of RTL design, verification, DFT, physical design. And
yes, sir.
to
True.
complete that tool, you need to learn the methodology also, that particular physical design methodology, verification methodology, DFT methodology. So this will not be taught after hiring you. Unlike software, you will not be trained after taking in, because everybody is too busy in semiconductor. And busy in the sense they have the entire software is completely different and semiconductor's work style is different. You are like a scientist. Remember that if you are working in semiconductor, you are a scientist. You take as much time as you want to debug and diagnose an IC. It's up to you. Okay. So it's a time taking effort, lot of what we call, you need to spend time, your brains, usage of innovations, your talent and skills to help diagnose the circuit. Okay, this is the issue in the circuit. This AND gate should not be here. This OR gate should not be here. Okay, the connection is wrong. So this knowledge you will get only through industry training. Okay, so within interview, when you enter into any company interview in a semiconductor, the first question he will ask is, he will take a circuit. Okay, this AND gate, NAND gate. Okay, is the connection correct? Any issue with the connections? The truth tables. Do you understand the concept of this? A half adder. Okay, you know half adder? How to understand the half adder? The realization of half adder. So whatever you learn in the academics is the same. Same questions will be asked, as I said. But after this question, next question will be, what is the tool that you got trained in? We use synopsis in our real time. If you are really learn that tool, then you are in. Okay, so they don't waste time, because semiconductor is little different. They don't spend money and time. They value each engineers, and you are very much valued. Unlike software, semiconductor engineer is so much valued in the company. Managers are afraid to talk to their own team members in semiconductor, because each engineer, even a fresher engineer, is equally valued to a 12 plus or a 20 plus engineer, years of experience engineer. So all are equally valued and respected in semiconductor, because the domain itself is so what we call valued. Okay.
Thank you, sir.
Yes.
Yeah, Zakir sir,
Any other
over to you.
queries?
Sir, I have one question about
Yes.
internship. Can we get an internship?
Yes, you can get an internship. We have internship programs. We provide internship.